Okay, in this example, I'm going to be working through the top two problems we see here, and what we're going to find out is that we don't get nice, neat values. Every problem that we've done so far has been like 30 degrees, 45 degrees, 60 degrees, stuff like that. So what do we do if we don't get a nice, neat answer? Well, first of all, in order to solve this problem, I know that I'm going to have to turn everything into tangents in order to solve it. I do that because I don't have an easy conversion from tangent to the first power to secant, but I do have an easy conversion from secant squared over to tangent squared. And so what I know is this. Secant squared is the same thing as tangent squared x plus 1. So I'm going to replace it with that. I'm going to write the rest of the equation out as follows, right? So the only thing I did is I changed secant squared to tangent squared plus 1. It's equivalent. Now I'm going to move everything to the left side. I'm going to write it like a quadratic equation. So I'm going to write the squared term first, tangent squared plus of x. I'm going to write the tangent of the first power next, minus 2 tangent x. And now, if I subtracted 4 from both sides, I would have 0 on the right, and I would have 1 minus 4, which is negative 3, on the left. Now, if you watch the video on factoring, you'll understand you can factor this just like x squared minus 2x minus 3. Well, if I think about it that way, then, I see that if I look at it like u squared minus 2u minus 3, I know that that factors out to u minus 3, u plus 1. So this is going to be the same thing, except instead of u, it's going to be tangent x minus 3, tangent x plus 1. So I'm jumping straight from here to here. The u thing just helps me visualize what's going on. That means I have two possible solutions at this point in time. Tangent of x can be 3, or tangent of x can be negative 1. Alright, so if I go through and I look at my all students take classes, I know that I have two answers here. They're going to be in the all quadrant, students, and in the take quadrant, right? And I know that the opposite is going to be 3, and the adjacent is going to be 1. Opposite over adjacent is 3 over 1. That's the tangent, right? Pythagorean theorem will tell me that 3 squared and 1 squared, that's 9 plus 1, add up to 10. So the hypotenuse must be the square root of 10. And I'm confused a little bit because I'm not used to working with the square root of 10. So if I wanted to know what the angle actually was, I would type in on my calculator at this point in time, batteries are low, I would type in arctangent of 3, and it's going to tell me, oh, it's 71.565 degrees. So we run across an issue here. If I don't get an angle that's nice and neat, if I get something that gives me a messy angle, the way that I state the answer is this. First of all, notice that this forms a straight line, right? So that means that this answer goes up in multiples of pi, just like the previous problems. But the answer, rather than say 71.565 degrees, I'm going to go ahead and leave it as the arctangent of 3. That's an exact value. It's really 71 degrees, but I'm also going to say that goes up in multiples of pi, and that's how I take care of the infinite solutions. So there's one of my answers so far. I'm going to do the same thing over here with tangent x equals negative 1. So I need two triangles on this problem. They need to be in the negative tangent quadrant, so that's in the students and the classes quadrants. And I know that the opposite and the adjacent are both 1. Now this one I know, because it's 1, 1 square root of 2. This is a 45-degree angle triangle. So my two solutions here, and I notice that they are in a straight line, so I can say this. This is 135 degrees, right there. That's 135 degrees. 135 degrees is the same thing as 3 pi over 4. So I have 3 pi over 4 plus multiples of 180 degrees afterwards in pi. And so my solution looks like this for the problem. One of them, nice neat angle, 45-degree angles involved. The other one, not so nice and neat, so I just leave it as arctangent of 3. And that came from this, right? X is equal to the arctangent of 3. Alright, let's do the same thing over here. Same answer, same problem, except that we might or may not have a nice neat answer involved. First thing I'm going to do here, everything's tangents. So I'm good to go with that respect, but I do need to get everything on the same side of the equation, so I can go ahead and I can factor. I need to factor 4u squared plus 5u minus 6 is equal to 0. Alright, so now I got to come up with a solution. I should have done this beforehand because I actually don't know what it is. So I'll show you my factoring method. If you don't know how to factor this on your own, you need to go look up some other videos because I'm not going to explain it here. Two values that multiply to give me 4u squared. 2u and 2u. Two values that multiply together to give me 6, 2 and 3. They're going to be opposite signs because of this. So maybe, this isn't going to work here. That would give me negative 4u. 6u, that's 2u total. That's not going to work. I'm trying to get these things to add up to 5u. Let's see. Maybe I go 1u and 4u here. So I'll guess and check. 4u times 2 is a negative 8u. 1u times 3 is a positive 3u. Aha! Here we go. I'm almost there. I'm almost there. It looks like this needs to be positive and this needs to be negative. 4u times 2 gives me a positive 8u. 1u times a negative 3 gives me a negative 3u. And 8u minus 3u gives me 5u, which is the middle term, which means this factors out to 4u minus 3u plus 2. If you have your own way of doing it, that's fantastic. This is just my way of factoring a tough equation. Alright, now, assuming we could get that step, which is pretty tough, to be honest, that's a pretty big step. But that means that this factors out to 4 tangent x minus 3 tangent x plus 2. That's equal to 0. From this, I can solve for tangent x, and I get tangent x equals 3/4. From the right one, I get tangent x is equal to negative 2. So now I need to go through, I need to figure out what my triangles are looking like. Alright, tangent is positive in the first quadrant, it's also positive in the third quadrant. The opposite is 3, and the adjacent is 4. If I do Pythagorean theorem, I find out that's a 3, 4, 5 triangle. Now it's fantastic that the sides are all whole numbers, but the problem is if I do the arctangent of 3/4, I get a messy angle. So I need to then leave this as then x is equal to the arctangent of 3/4. And then to take care of the infinite solutions, I notice that they go up in multiples of 180, so it's plus n pi. There's my first solution. So this is exact instead of 36.869 degrees. I'm going to leave it like that. The other one, tangent x is negative 2. I know that tangent is negative in the second and the fourth quadrants. I know it has an opposite of 2 and an adjacent of 1. And if I go through and do Pythagorean theorem, I know that this isn't even possible. Oh, adjacent of 1, not hypotenuse of 1. There we go. 2 squared is 4, 1 squared is 1, 4 plus 1 is 5. This is the square root of 5 according to Pythagorean theorem. I don't know how to work with this. And in fact, if I go do the arctangent of negative 2, I get a messy value, right? So we're going to go ahead and leave this as x equals, and we're going to go ahead and rather than put in the messy angle, we're just going to go ahead and say it's the arctangent of negative 2 plus n pi. Why n pi? Because I notice once again these things are paired up. They go 180 degrees, right? And this is exact as I can get. So that's what we do with problems whenever we don't have nice, neat angles to put in.